So how can we find the area of this circle here, which is inscribed in this triangle with sides 5, 12, and 13? By the way, this circle is called the incircle of a triangle, and one fun fact is, this is the biggest circle that you can inscribe in a triangle. Another fun fact is, there's a nice way to do this particular question. Check this out. To find the area, of course, we need a radius. I will just say it looks like this right here. Radius equals this side times that side, which is 5 times 12, and then divided by the perimeter of the triangle. So let me just add them up. So the top is 60, the bottom is 30, so the radius is equal to 2. And then, of course, the area of the incircle in this case is just pi times the radius, and then square that, and we have 4 pi, and then we are done. Seriously. So now I'm going to show you guys why this is true, and I'm just going to do it with right triangles first, and you can generalize it to any triangle. So have a look. Let's say we have a right triangle here with sides A, B, and C, where C is the hypotenuse, and then let's say here is the incircle of the triangle. And let's say here is the incenter, which is the center of the incircle. So we have the radius from here to here. Likewise, this is also the radius. Likewise, that is also the radius. Now have a look. Let's focus on the big triangle. How can we find its area? Well, this is the base, this is the height. So it's just 1/2 base times height. Let me write it down as AB. This represents the area of the big triangle. Now, I want to relate this triangle with R. To do so, I'm just going to break down this big triangle into 3 smaller ones. To do so, I'm going to connect from the incenter, which is the center of the incircle, just connect it to here, and then connect it to here. So this one is the first one, second one, and then the third one. 3 smaller ones. So that means if you look at the whole triangle, which with the area 1/2 AB, I can actually look at this triangle first, take this for the base, and then the height will be what? In fact, will be the R, because we have a theorem says that if we have a circle that's tangent to a side, then the radius is going to be perpendicular to the side. So base times height. So we will have 1/2 times A times R for this triangle here. And then let's do this one. Take this for the base. Again, this will be the height. So add it with what we had earlier. And then lastly, take this right here for the base. Take this for the height. So we have plus 1/2 CR, just like that. Now everybody has 1/2, so we can multiply this entire equation by 2, so the 1/2 doesn't matter anymore. So we can see AB is equal to, and then they all have R, so we can factor that out. And then we will have A plus B plus C. Then divide this to the other side. You can see that R is just equal to AB divided by A plus B plus C, which is the perimeter of the triangle. The top is just this times that, like A times B, just like this. So this right here, it's for right triangles. It works wonders. And now if you have any triangles, well, check this out. This is just a triangle with sides A, B, C, and our goal is still to find the radius of the incircle first. So let's say here is the center, here is R, and here's R, and here is also R. Well, I'm just going to break it down into 3 parts. So the whole area will be, again, do like this. So the first part is, take this for the base, that will be the height. So we have 1/2 A times R, and then do the same thing, 1/2 B times R, and then lastly 1/2 C times R, same thing. Have a look here though. I'm going to factor out the R. And then I'm going to write it as A over 2, B over 2, and C over 2 and add them up, right? I'm just going to put it A plus B plus C all over 2. This expression actually has a name. The top A plus B plus C is just the perimeter of a triangle. And when we divide it by 2, it's called the semiperimeter. And the usual notation for that is S. So this is the semiperimeter. Cool. Now, on the left-hand side, we will need to figure out the area of the triangle. Well, if we know all 3 sides of a triangle, in fact, we can use Heron's formula to help us out. But for now, let me just write it down. Area is equal to R times S. So the radius of the incircle is just going to be area divided by S. And for the area, here is the Heron's formula, which is also related to S. We can write this as the square root S times S minus the side A, and then S minus side B, and then S minus C, and then all divided by S, like this. Right? So from here to here, this is the Heron's formula. And if you want to see the proof for this formula, you can check the description. That's it.